question, it's from quadratic polynomial. It's relatively simple compared to the previous one. If a minus 2x square plus 3x minus 5 is a quadratic polynomial, then it's given for options based on the values for a. A can take any real value, a can take any non-zero value, a not equal to 2, a equal to 2. This is from the basic definition of a quadratic polynomial. If it's a quadratic polynomial, the coefficient of x square cannot be equal to 0. So you can, from this, x square term must be there if it need to be a quadratic polynomial. So a minus 2 cannot be equal to 0. That means a cannot be equal to 2. So your answer will be option C, a not equal to 2. Next question, if zeros of the quadratic polynomial f of x is equal to x square plus 4 into x square plus 7x plus 4k are reciprocal of each other, then the values of k is. So in this question, it's given that the zeros of the quadratic polynomial are reciprocal. So let alpha and beta be the zeros. So from the question, it's clear that beta can be taken as 1 by alpha. So the product of zeros, alpha into beta, it's normally written as c by a based on the coefficients. That's equal to, you can replace beta with 1 by alpha. So this is equal to alpha into 1 by alpha. That's equal to c by a from the given polynomial. So alpha into 1 by alpha will be equal to 1. Since alpha will get cancelled, and you will be getting 1 is equal to c by a. So from this polynomial f of x, you can find the values for c and a. C is equal to 4k. The value of c will be 4k. And coefficient of x square, all the terms coming along with x square can be considered as a. So that will be k square plus 4. In this question, b will be 7. Since it's 7x, b value is 7. But we need only c by a. So substitute the values for c and a. So that we can replace this as c by a is actually 4k by k square plus 1. C by a is equal to 4k by k square plus 4. That's equal to 1. So cross multiply, then we will be getting a quadratic equation and solve for that. So on cross multiplying this, you will be getting k square plus 4 is equal to 4k. And rearrange that, you will get k square minus 4k plus 4 is equal to 0. So you can factorize this either by splitting the middle term or by quadratic formula. In this case, if you are splitting the middle term, k square minus 4k, I'll be representing that by minus 2k plus 4 is equal to 0. So I can take common, so that k into k minus 2. I'll take minus 2 from these two terms, so that it will be minus 2 into k minus 2 is equal to 0. So can take k minus 2 common now. So k minus 2 into the remaining things will be k and minus 2. So k minus 2 is equal to 0. This is actually k minus 2, the whole square is equal to 0. Or you can equate either of these to 0 and you will be getting the value for k. Since both these factors are same, you will be getting only one value for k. And the value of k will be k minus 2 equal to 0. That means k is equal to 2. So your option is answer option C, 2. So another question from polynomials. If alpha, beta are zeros of the polynomial f of x is equal to ax square plus bx plus c, then 1 by alpha square plus 1 by beta square is equal to. This can be asked in many different ways. It can be 1 by alpha plus 1 by beta equal to. Such questions you can expect. In this case, it's not 1 by alpha plus 1 by beta. Instead of that, they have given 1 by alpha square plus 1 by beta square. So I have written something on the board. It's like 1 by alpha square plus 1 by beta square. On cross multiplying this, it will be of this form: alpha square plus beta square by alpha square into beta square. So alpha square plus beta square can be rewritten as alpha plus beta the whole square using the identity a plus b the whole square. When it's expanded, you'll be getting a square plus 2ab plus b square. So here we have only the square terms in the numerator. So we need to subtract the 2ab term. On expanding this, alpha plus beta the whole square, we'll be getting 2 alpha beta. On subtracting that, this will be of the form alpha plus beta the whole square minus 2 alpha beta whole divided by alpha beta the whole square. Since it's written alpha and beta squares separately, so we can combine that using the laws of exponents and can be represented as alpha beta whole raised to 2. Now everything is known to you. you can find alpha plus beta. What is alpha plus beta? The sum of zeros is minus b by a. Alpha beta, the product can be written as c by a. Again, this alpha beta can be replaced with c by a. Now I have one expression in terms of b and a. So on squaring here, that will be b square minus b whole square will be b square by a square minus 2c by a whole divided by c square by a square. Now you can look into this. Here only a is there. So on converting this to a square, the numerator I need to multiply with 1a. So that can be replaced with ca or ac. So here everything is in ac. You can write that in this form, 2ac divided by a square. Now these are like fractions. You can straight away perform the operations in the numerator. So it can be rewritten as b square minus 2ac whole divided by a square. This division can be replaced with this division divided by c square by a square. So that can be written as c square by a square. Again, this by taking the reciprocal and multiplying, finally you will be getting the answer. A square by c square. These a square will get cancelled, and finally you will be getting b square minus 2ac divided by c square. And you have one option in that. That's option B, b square minus 2ac divided by c square. So option B is your answer.